Hey everyone, this is Sandip back with another video. And in today's video, I'm going to talk about recursion. And one of the difficult topic for a beginner, at least if you're not an experienced developer. That's why I have kept this warning here. I've kept this warning, not to afraid you actually. I mean, recursion is intimidating, but can be learned through visualization practice. Now, this visualization concept, I brought it up here, and practice. I keep saying, if you practice something like too many number of times, it builds into your muscle memory, and then you can crack anything. But I have created some visualization to understand recursion pretty well. If you go down right, this call stack, this thing, I have created. I think this is going to help you understand recursion in a pretty easy manner. So stick to this video until the end. And I think so this video is going to give you the idea how recursion work. We're going to see some practical example also. I'm planning to come up with another video where I'm going to have more practical example with all of this visualization, and that's going to help you crack recursion in much simpler manner. So it's intimidating, but visualization and practice, we're going to do some practice. You're going to code along with me and it will be easy for you. Okay, so let's jump into the real world example. I have just created, like you and something like, so think like you or me or anyone like someone sitting here, maybe on the dining table. And if you want to eat chapati, right? Chapati, or if you're watching out of India, right? In India, we eat a lot of chapatis here, but maybe a tortilla or tortilla is a word. I don't know. You can correct me in the comments. Maybe I heard about that word even when I ate that when I was in US. So tortilla, chapati, whatever, right? So it's like take this example where if you want to eat chapatis, right? And if there are 5 chapatis on the table, on the dining table, right? You're going to eat chapati number 5, then chapati number 4, then 3, then 2, then 1, and then 0. So there will be no chapatis. So obviously you can't eat anything there as there are no chapatis, right? So here we need to focus on two things actually. The first one is the task which is happening here, and it's a repetitive task, right? So the repetitive task in this real world example is eating chapati, but different one each time. Now this is a really important point I want to make here. You're eating chapati, but each time you're eating different chapati. Maybe the first chapati shape is round, maybe the second one is not that rounded, maybe the first one is maybe a little bit dark, or third one will be a little bit light in color. So it depends, like every time you're eating chapati, but each chapati is different. That's really important point. So the data is different here. And the second thing which I like to talk about is the condition. And you're going to eat chapati until they are left on the table. Now, this is also important. So now let's try to implement this example. Now, eating chapati will be a program I'm going to create in front of you. Now, there are two ways of solving the problem. I mean, there are multiple ways, as I did in my previous videos, but there are two ways to majorly solve problem. One, repetitive problem, the repetitive task. One is you can use the for loop, like in this example. Maybe if I want to create this program of eating chapatis, right? I can use a for loop, and there is another way which is called recursion, where we can use that repetitive task and we can put some condition to end that particular task. So let's do this. Let's jump into our code editor, right? And I'm going to create a new, what's running here? I'm going to create a new snippet here, and let me name that snippet chapati, or maybe counting. Let's do a counting. I'll name this as a counting, but I'm going to write a function here, and that function will be named as eating chapati, just to keep it really simple, and I'm going to pass a number as an argument which says, right, how many numbers of chapatis you're eating actually. Okay, so the one of the solution I can implement is I can use a for loop here, and I can say let I is equals to, maybe I can do something like this. Let I is equals to 0 until I, or maybe I'll start with I as a number, right? I as a number until I is greater than 0. I'm going to say I minus minus. So I'm eating chapatis in the reverse order 5, 4, 3, 2, 1, 0, something like that. So I'm going to just console.log here, console.log, and I'll say, hey, I'm eating chapati, and then probably I can give that number here, right? I'm going to use I. So I start with the number actually. So initially, right? So I'm going to call this function now, eating chapati, and let's give it a number 5 as an input. So what's going to happen right here? Let's do that with a comment. So eating chapati is going to get called. It's going to get pushed into the call stack. I'm going to talk about call stack. So number is 5. Now I is equals to 5. 5 is greater than 0. That's correct. So I'm going to say eating chapati number 5. Okay, so initially I will be 5. Obviously 5 is greater than 0. So I'm going to say eating chapati 5, something like that. Okay. Then now I'm going to say I minus minus. So I is going to become 4. And then again, I'm going to say check whether I is 4 is greater than 0. Yes, 4 is greater than 0. So I'm going to say eating chapati number 4. Then I minus minus. Again, I is going to become 3 now, right? I'm going to compare 3 is greater than 0 and so on and so forth. I mean, I'm just going to straight away write it down, right? Next, I is going to become 2. Okay, 2, right? Eating chapati number 2. Now, I is going to become 1 and I'm going to check whether 1 is greater than 0. Yes, 1 is greater than 0. So I'm going to say eating chapati 1. Now, I is going to become 0. And this time, 0 is not greater than 0. All right. So I'm going to come out of the loop. So my program is done. Done. Something like this. So let's run it and see. So you see that, right? Eating chapati 5, 4, 3, 2, 1. Once it is 0. So if you look at this program, this is one way of solving this problem which we call a iterative approach using a for loop, right? There is another way of solving this particular problem, which is called a recursion. And recursion is nothing but, if I scroll down here, recursion is nothing but a process or a function that calls itself. Now here, if you look at the task, what is the repetitive task here? Eating chapati, right? So can I have something like this? Maybe eating chapati is calling eating chapati itself. Sounds little hair pulling thing, I would say. So but it's not difficult. So a recursion is a process in which the function that calls itself. So now we need to consider two different cases here. One is a task, a function call with different input. As I said, right, eating chapati, but with different one each time. And the base case, condition to end the recursion. Now you can use recursion, but you need to use recursion in the right way. You need to have that repetitive task with different data input, and you need to have a base case condition to end the recursion. So let's do that. I'm going to show you one example here. So I'm going to comment this one. Let's convert this program, this for loop into a recursion. So in recursion, we will have a function. We're going to have a function eating chapati, right? And again, it's going to take a number as an input. Again, I'm not coming out of the round brackets. Okay, eating chapati, right? Now, eating chapati, first of all, eating chapati is going to call eating chapati once again and again, basically. So it's what is recursion again? I'll come back again. I'll repeat again, a process or a function that calls itself, right? So eating chapati here is calling eating chapati, right? But we need that number as an input, right? So I'm going to pass number also. So initially, maybe like I'm calling this eating chapati with 5 as a number. So 5, and I'm calling eating chapati with 5. So again, eating chapati is getting called by 5, 5, 5, 5. But I said, right, function call with different input. So initially, I'm going to eat the chapati, but I'm going to eat chapati number 5. Next time, I'm going to eat the chapati, but I'm going to eat chapati number 4. So just added a simple statement here, right? Number minus 1. So initially 5, then 5 minus 1 will be 4, then 4 minus 1 will be 3, then 3 minus 1 will be 2, then 2 minus 1 will be 1, then 1 minus 1 will be 0. Let's do this. I mean, let's run this simple program, where I'm calling the eating chapati, and I'm going to do the console log also. Like I said, right, console.log, and I'm going to print the same thing here, eating chapati, right? and then I'm going to use the number. So initially I'm going to eat the chapati number 5, then number is going to change to 4 minus 5 minus 1, that is 4, so eating chapati number 4. Let's run this program and let's see what happens, and you'll see something strange happening here. See that? So my program, it went into something called an infinite loop. So browsers are smart enough, right, to handle such a situation, and this program wouldn't have ended actually. Infinite loop means keep running, keep running, keep running for infinite number of times. I mean, it's never ending. It's not going to end. So, but our browsers nowadays are smart enough. They have stopped this program from running that many number of times. Maximum call stack exceeded. Now, this is really important warning, right? Maximum call stack exceeded. Let's go back to our, like where it started, Okay. Can I use something like a home button or something? I don't know. I'm not able to find the scroll bar. Okay, got it now. Oh my goodness. Why it's not working the way I want, man. Okay, let me try to scroll up a bit and then. Okay, now I got hold of the scroll bar. So you see that, right? We started with eating chapati 5, 4, 3, 2, 1, 0. Then -1, -2, -3, because there is nothing like a base case or a condition to end the recursion. Now this program is working perfectly fine. You see here, right? Eating chapati 5, 4, 3, 2, 1. We are doing the task of eating chapatis pretty well. We are eating them, but we are eating the infinite number of chapatis. So we need that base case, that condition to end this situation. And what is that condition for this particular program? You're going to stop eating chapatis, as I said, right? You're going to stop eating chapatis once they are not left in the table. I mean, there were no more chapatis on the table, right? And we don't have that condition here. I just need to put that condition here, maybe something like this, not here, but here, where I'm going to say if what is a chapati here, that number, right? If number is equals to 0, I mean, if there are 0 chapatis on my table, I'm not going to eat anything, right? So I'm just going to return. I'm not eating chapatis no more now, right? And now if I clear this and if I run this program, see that now this is working perfectly fine. Eating chapati 5, 4, 3, 2, 1. So you can see like there are two different ways of achieving the same problem statement of eating chapatis. One with a for loop and one with a recursion. Now you must be saying, I mean, why to wrap your head around it, and learn this function calling itself? But there are some advantages of, using recursion instead of for loop, and we will see in the upcoming videos also where I'm going to use recursion instead of for loop for solving the problems. There's nothing wrong in using the for loop. I mean, it's a proven way. You can use for loop, but using recursion sometimes help. So it's a good idea, right, to learn recursion, to understand recursion. And I think I made a justice here by giving this eating chapati example, the real world example, where how you can call the same function and how you can put that base condition to end that repetitive task. It's like running, but you need some end, right, where you're going to stop running, that end line. That end line is nothing but that base case, and your task is nothing but eating chapati, that running task. So I think pretty easy to understand, right? So, and recursions are important from the interview perspective. Also, interviewers like asking questions related to recursion. So it's always a good idea to understand recursion to its depth. Okay, so I think this sounds good. I think you understood. I'm going to just quickly recap that recursion is nothing but a process or a function that calls itself. That's a function call with different input, and you should have two things. I mean, task and base case. So task is function call with different input, and base case is nothing but condition to end the recursion. And we did that, right, with this really simple, pretty easy real world example. Now let's move on. Let's try to solve a problem which is not a real world, but very interesting, like, uh, related to calculating or finding a factorial of a number. Now this is a really popular problem with generally, people ask to solve this particular problem with a for loop, and to solve this problem with the help of recursion also. Now first of all, if you don't understand what is the meaning of factorial, I'm going to explain that. So I'm going to create a new snippet here. I'm going to name it Factorial And let's write a function. Okay, first of all, I need to explain what is factorial of a number. If you don't know, so if I say 3 factorial, now this is a symbol way, this exclamation mark is nothing but a factorial. So factorial of a 3. Factorials are basically calculated around numbers. So factorial of a 3 is 3 into 2 into 1. It's nothing but, doing the multiplication in the reverse order. So factorial of a 3 will be 3 into 2 into 1. 3 to 6 and 6 ones are 1. Sorry, 6 ones are 1. Yes, 6 ones are 6. And I'm fumbling around with my tables here. Okay, 6. Let's take another example. Maybe let's take an example of 5 factorial. I'm going to say 5 into 4 into 3 into, what am I doing? Into 2 into 1, something like that. Okay, now this is a big one. 5 fours are 20, 23s are 60, 62s are 120, 121s are 120. So 120 will be the answer. So this is what the factorial means. So given a number, you're going to multiply them in reverse order, and whatever you get out of it is your factorial of that particular number. Really easy. Now look at it. Look at this particular problem statement. What's going on here? What is a repetitive task in this particular example? Can you find it out? It's multiplication, right? It's multiplication of all those numbers in the reverse order. So there are two ways of solving this problem, right? You can either use a for loop, or you can use the difficult thing called recursion. So let's try this problem statement using for loop first. So I'm going to say function. I'm going to write function, and let's name it factorial. It's a real factorial. I'm going to take number as an input, and obviously, so I'm using the for loop. So I'm going to run the for loop first. So let's write a for loop. Let I is equals to, now I is equals to, again, see, the multiplication is happening here, right? So I'm going to say number. So initially I'm going to start with I equals to number until I is greater than 0, because we don't want to multiply with the 0. And then I'm going to say I plus plus. Okay, so I'm going to replicate the same thing here, right? So I'm going to take number 5, then I'm going to multiply by 5 with 4, means number minus 1. So before doing before doing that, I need some variable here, maybe like total variable I'm going to create, where I'm going to store the result. So initially I'm going to start with the total of 1. So what I'm going to do is I'm going to take total here, and I'm going to say total is equals to total into I. So initially it will be 1 into 5. I mean, this one I am taking. So 1 into 5, something like that. Then it will be the 1 into 5 will be 5, right? Then I is going to be minus minus, not plus plus. And finally, I'm going to return my total here. Okay, so let's call the factorial function, and I'm going to run through it. Let's take the example of 5 only. Okay, so what's going to happen here, right? So I'm going to put some comments. So factorial of 5, so total is going to be 1, right? I is going to be 5, right? So total 1, I is equals to 5. 5 is greater than 0? Yes, 5 is greater than 0. So total equals to 5, 1 into 5. So initially I'm doing 1 into 5, and that will give me the result of 5. So that will be stored into total, right? So my total is going to become now 5. Now the actual thing will start from here, right? Now I will become 4, because I am doing the I minus minus here. So I will become 4. Now I'm going to multiply 5 into 4. See, now the actual real loop has been started. I'm going to do 5 into 4, then 4 into 3, 5 into 4, then the result of 5 into 4 into 3, then result of that into 2, and then result of that into 1. So 5 into 4 is equals to 20, right? So now my total is going to become 20. Oh my goodness. Why this is taking that auto suggestion part? I really don't understand. Now total is going to become 20. Now I is going to become 3. Okay, so I'm going to multiply 20 into 3. That will become 60. Then again, I'm going to paste, put the comment. Now total will be 60. I is going to become 2, right? I'm going to take 60 and 2, that will become 120. And finally, I is going to become 1, 121, and 1 is greater than 0, obviously. So I'm going to take 120 into 1, and that will give me again 120. Actually, you don't need to do this last step, maybe you can do just I greater than 1, but let's keep it simple, that one more multiplication is not going to harm you much. So let's keep it. Now I is going to become 0. Okay. So I'm going to put it as a comment. So total is 120, right? I is 0 now. So 0 is greater than 0. It's going to fail. It's going to come out of the loop and it's going to return 120 as an output. So this is how this program is going to run when I've used for loop. So let's test this program, whether we are getting the right factorial of a number. See that we are getting 120. Let's try with 3. Wow, you're getting 6. Let's try with some bigger number, maybe 10. I don't know what is the factorial of 10. Great, let's try with some other number like 7. Great, let's try with 0. 0 should return 1 actually. Okay, you're getting 1. So as I said, right, you can use for loop to have a factorial of a number. But now I'm going to apply a recursion to this problem statement, and I'm going to do that repetitive task of multiplication using a recursion, using a function that calls itself. So what is recursion? A process, a function that calls itself, right? Now, what is the repetitive task here? The multiplication, and we're going to put the base condition also, but we'll start with a simple thing first. So I'm going to write my factorial function again, but I need to call it a function first. And let's give it a number as an input. And factorial is going to call factorial, but with different inputs. So I need to have a factorial of number minus 1 basically. See, same thing you need to do here, right? You need to change the data. You can't always pass 5 to the factorial of 5. So factorial of 5 is going to repeat because you're not changing the input, and that's the condition where we have recursion, where the task should have different input each time. So I'm going to call factorial of 5 right here. I'm calling factorial of 0, not 0, 5. Okay, and what it's going to do, right? It's going to call factorial of 5 minus 1, 4. Then number become 4, right? Then it's going to call factorial of number minus 1, is 4 minus 1, 3. Then 3 minus 1 will become 2. So it will call factorial of 2. Then 2 minus 1 will become 1. Then it will call factorial of 1. So basically what we are doing, if you look at it, it's basically doing the calculation individually. First I'm calling the factorial of 5. I'm multiplying that with a factorial of 4. I'm multiplying that with a factorial of 3. I'm multiplying that with a factorial of 2. And maybe I'll take this down from here. So, and finally, I'm multiplying factorial of 1. So basically, I'm doing, and this is the spelling mistake I did, Factorial here. So maybe I need to copy and paste. Factorial. What is Factorial, man? Okay. So first, I want to have a factorial of 5. Then I'm going to have factorial of 4, then 3, then 2, then 1, and I'm going to multiply all of them together. Something like that. So repetitive task, right? And we need to return that. Return factorial of a number, but we need to do this multiplication also. So I'm going to do something like this. I'm going to say return number into factorial of a number minus 1. So see, I'm running that formula only through this particular program. If you see here, right? So I'm saying take the number, I'm going to take the 5 and then multiply that with factorial of number 1. So basically I'm doing this, not 5. I'm basically calculating the factorial of 5, but something like this. 5 into, take me first find out the factorial of 4, then find out the factorial of 3, then find out the factorial of 2, and then find out the factorial of 1, something like that. Basically, it's all about, returning that multiplication value only. So number into factorial of a number minus 1. So 5 into factorial of 5 minus 1, that is 4. So how? So this is how it is working, factorial of 4. Then now number is 4, so it's going to come back here and it's going to say number. So again, it is going to say 4 into factorial of number minus 1, that is 3. So 4 into factorial of 3, then 3 into factorial of 2, and then 3 into 2 into factorial of 1, and then finally we need to put some base condition also. So now if I run this program, obviously it's going to go into the infinite loop, but let's try that. Let's see what happens. You see that, right? Maximum call stack exceeded, because I'm calling that function again and again, but I don't have a base condition. Now try to understand or try to identify what is the base condition in this problem statement. And that's pretty easy, right? If number, so when number is equals to 0, obviously when number is 0, I don't want to find out the factorial of that particular number. I'm just going to return 1 from here. Because I know factorial of 0 is 1. That's where the, the solution of this problem starts. So when we hit this number as 0, I'm going to return 1, because I know factorial of a 0 is 1. Pretty simple, right? So, or maybe I can just try with 1 only. So maybe like, but I need to see the output first. So let's try to run this program first. So factorial of 5. Okay, again, it's running through number equals to 1. So I'm checking, yes, number equals to 1, return 1, else return number. Something is wrong. I'm getting the result, right? 120. I need to check whether what is the output I'm getting for factorial of 0. See, I'm not getting anything. It's running into that maximum call stack now. So I need to check that here. So number equals to 0. Maybe let's try this. And I'm going to close this. So factorial of 0 is 1. Let's try. I'm going to explain the problem also. Let me run through it first. That's 120. Very good. Let's do for 3 also. That giving me 6. Okay, so we're getting. Now let's understand this particular problem, through something called a call stack, which I have created here. And I'm going to run that call stack here also. So first, let me go back to my nodes. I'm telling you a very, very important thing about this. Let's run through this program. And I think I need to bring this program and these slides here, so we can do the compare and contrast. So I'm just going to open my inspect elements panel here, and I'm just going to bring it here, something like this, and then we are going to do the comparison. Okay, let me do some adjustment. Okay, so when we call a function in JavaScript, I need to open the sources panel also here. So I'm just going to open that, and we are looking into factorial, right? And we are running through this problem statement, right? So when we call any function in JavaScript, it gets pushed into something called a stack. A stack is nothing but, stack up those chapatis or stack up those plates on the dining table, right? So the stack is going to start from bottom up, and then it's going to get executed from top down, some bottom up, top down, something like that. So what's going to happen when I'm going to call this factorial of 5, all right? So it's going to call this function factorial. So now the number is 5, right? I'm going to check the condition here. Number is equals to 1. Instead of that, I should put 0 here. So this is this slide. I'm going to change it to 0 because I think that's the right condition. So let me change it now only, so that we are going in a right direction maybe. So let me do that for you. Okay, so now this is looking good. So now 5 is equals to 0. No, 5 is not equals to 0. So it's not going to say return 1. It's going to return 5 number, that is 5 into factorial of a number minus 1, means factorial of 4. You're getting, so nothing has actually happened in the program now. If you just look at it, we're just saying 5 into factorial of 4. That means another function call into the stack. Okay, so now this time number is going to become 4 because I set factorial of 4, right? So now I'm going to check 4 equals to 0. No, so I'm returning 4 into factorial of 3. See, still no multiplication has happened yet. There's no multiplication happened yet. We're just pushing things into the stack. Okay, now factorial of 3 is again going to change the number to 3, right? So now I'm checking 3 equals to 0. No. So return 3 into factorial of 2. Again, nothing has happened. No multiplication has happened. So I'm going to call factorial of 2, right? So number is going to become 2 here. So 2 equals to 0. Return 2 into factorial of 1. You're getting my point? Now factorial of 1 number is going to become 1. So I'm checking whether number is equals to 0. Now again, actually, probably I need to return factorial of 0 here. Or maybe, for the sake of simplicity, I'm just going to keep it number 1 only. And I'm going to undo some part of it so that, or maybe I need to add something into the stack, or maybe I will undo. I mean, I know this is going a little bit wrong, but maybe I'll put 1 here. And I'll try to come back again. Okay, I think this looks easy, right? So we started with 5, then 4, 3, 2, 1. Now number is equals to 1, so I'm going to return 1 here. Actually, we need 0 here, but that's okay. So return 1. So what's going to happen here, right? So return 1. So I'm returning 1 now. It's like, we are pushing things into the stack. I'll give you a very, very good real world example here where you're like buying products from Amazon, but you haven't opened those products yet. That could be a very good example, So you bought the product here, you bought the product here, you bought the product here, you bought the product here. But actually you have started opening those products after the product number 5. That's this return 1. So I'm going to get back that return 1, and now the real meat, real execution start. Now the last function, the factorial of 1, is going to return me 1. I'm going to multiply that with 2. So that's going to return me 2 into 1 is 3. Sorry, 2 into 1 is 2. So I'm going to get back 2 here. Then I'm going to multiply that with 3. 3 into 2 is 6. I'm going to multiply 6 with 4. 6 into 4 is 24. And then I'm going to multiply 24 with 5, and that is 120. So actual multiplication or actual execution of program, it happens only after this return statement. So I'm going to update the slides also. So you get that? I mean, in fact, in recursion, actually, first you do the work, you push things into the stack. And the actual execution happens after the base case has executed. Once the base case has returned something, then, the actual multiplication start. That's where, so basically repetitively we are doing multiplication here. 1, 2 into 1, then 3 into 2, then 4 into 6, then 5 into 24. So basically it's a repetitive multiplication which is happening in case of recursion. And if you don't put that base case right, your recursion is not going to work. So I think I'll go back here and I'm going to close this. Hopefully you have understood what I'm trying to say here. Maybe I need to save it first. Okay. And then I'm going to close it. Okay. Already closed. So to understand recursion, right? I think take a screenshot of this call stack. I think it's really easy to understand, visualize your call stack, and then see how things are working. So I'm going to show you this call stack, how this call stack thing is working. So I'm going to put a breakpoint here, something called a breakpoint, and I'm going to run this program now, and we'll see how things are happening really in the call stack here. So this is a call stack here. I'm going to run this program. Okay, so factorial of 5. I see the call stack empty here. But there is something called an anonymous function which has been called. So now I'm going to run this. So this has called a factorial function, right? And this time number is 5. That's what is happening, right? And the number is 5. And I'm going to call another factorial function now. So I'm going to say, run this now. So I'm going to check number 5 equals to 0. No. Return 1. No. Return number into factorial of 4. This is what is happening. 5 into factorial of 4. Okay, so if I run this again, you see that I'm again calling the factorial. So you see another factorial has been pushed. This one now, this one has been pushed, and now the number is 4. 4 is equals to 0. No, 4 is not equals to 0. So I'm going to run this again. It's again going to say 4 into factorial of number minus 1. So 4 into factorial of 3. Same thing happening, right? So you'll see another factorial getting pushed into the stack. See that? Another factorial function has been pushed into the stack now. and this time the number is 3, and the same thing is going to happen. 3 is not equals to 0. Again, it's going to call a factorial. Another factorial has been pushed into the stack. Again, 2 is not equals to 0. Again, another factorial has been pushed into the stack, and 1 is not equals to 0. Hence, again, another factorial has been pushed into the stack. And now number is 0. And now this is the place where, you bought the products from Amazon, right? And now you're opening it. Now the program is opening up. Now I'm going to return 1, and that 1 is going to get multiplied with the previous results of factorial. So one by one, we are going to grab things out of the stack now. So see, now 1, 2, 3, 4, now 3, now 2, now 1, and now finally, we have the output 120 here. So this is how actually factorial works in real world. I think go ahead and look into this stack, draw this stack by yourself just to understand what is happening here. I mean, it's a holding thing, I mean, actual execution is not happening until the base condition has been satisfied. And once the base condition is satisfied, then actual calculation works. That's why, this is where the bottom to top we are going, and then top to bottom we are coming. So here we are just pushing things into the stack, and here the actual calculations are happening when we are returning the values. So hopefully, I think a quick recap. So you can solve many problems using recursion, and I'm going to come up with some of the problem statements, and I'm going to solve in front of you. I'll try to create all of this call stack example also here. So just for the sake of revision, right? Repetitive task where you're going to use recursion, repetitive task, like we talked about eating chapati example, where you're going to eat chapati one by one, but each time the chapati is going to be different, and you're going to eat chapatis until chapatis are left on the table. So recursion is a processor function that calls itself. So we have two different elements here, task function call with different input, and a base case condition to end the recursion. We have seen the example with the call stack. We have solved the factorial using recursion. So I think that's it for this video. I'll come up with more examples on recursion. Until then, you practice this, take a screenshot of this particular slide, try to create it by yourself, and I think you should be able to understand recursion pretty well. Until then, I'm going to say you take care, goodbye, and I'm going to see you in the next video. Thanks for watching.